So strong acids are those that completely dissociate in solution. They don't have an equilibrium reaction. What they have is an arrow in one direction. Weak acids are those that don't dissociate completely, and they have an arrow that looks like an equilibrium reaction. Strong bases are those that are formed from group 1 and 2 with the OH minus ion. Weak bases are anything else that doesn't have metals from group 1 or group 2. So let's identify these acids or bases as a strong or weak. This is a strong acid. This is a weak acid. This is a strong base. This is a strong acid. And this doesn't have a metal from group 1 or 2, so this is a weak base. The dissociation of the acids is gonna depend, since the weak acids go in an equilibrium reaction, so they dissociate, and we can write the equilibrium constant of this reaction like we did before, concentration of products over concentration of difference. Let's talk now about the ionization of water. When water is with another molecule of water, one reacts as an acid and the other one reacts as a base. To give you these products, this is the conjugate acid of water and this is the conjugate base of water. Based on this, we will have the following equation. We're going to be working with this equation for the rest of the chapter. The Kw, this is the constant of dissociation of water, is going to be equal to what? The concentration of H3O plus times the concentration of OH minus. At room temperature, the value of Kw is equal to 1 times 10 to the negative 14. Pure water is neutral because the concentration of H3O plus and the concentration of OH minus are the same. So when we have acid solutions, the concentration of H3O plus is greater than the concentration of OH minus. And when we have basic solutions, the concentration of OH minus is greater than the concentration of H3O plus. So let's use the formula that we've been talking about. Kw equals concentration of H3O plus times concentration of OH minus to use this problem. And remember, the value of Kw is equal to 1 times 10 to the negative 14. And it's a given. You will always have this value with you. So the question is giving us this. We have this. We need to find the concentration of OH minus. So we solve concentration of OH minus equals the Kw divided by the concentration of H3O plus. So we substitute our values and we say concentration of OH minus is equal to the value of Kw divided by the concentration of H3O plus given by the problem, and we do the calculations and we end up that the concentration of OH minus is equal to 2 times 10 to the negative 7 molar. These concentrations are in terms of molarity. For the next problem, they are giving you a multiple choice problem. They are giving you H3O plus, the concentration. They want this one. So what we're going to do is use the same equation that we used previously. Kw equals concentration of H3O plus times OH minus. We have this and we have this. We're going to solve for OH minus. Will be Kw over concentration of OH3O+. Substitute our values. 1 times 10 to the negative 14 over 2 times 10 to the negative 3. When we do the math, we find out that the answer is C.